Okay, everyone, follow my lead. Please tell me, can you move your right hand? Just tell me. Now, can you show me how you move it? Raise your right hand. The right. Okay. What if I told you you're not moving your hand and you'll be stuck here for a month? You can't leave. This is what patients with hemiplegia feels like. They feel like they've been lied, deceived, and they're prisoners in the hospitals because they're completely fine, even though they had a stroke and they were diagnosed with completely hemiparalysis. So they can actually not move their hand. This is a condition that is called anosognosia for hemiplegia. It means the lack of awareness of one's own motor abilities. And this is one of the rare uncommon syndrome that I've been studying during my PhD. If you put your feet in the shoes of the patients who completely deny their problems, and if I were to told you, since tomorrow you're going to start a very hard training for your right hand, you're not engaging because you're fine. You're sure you're fine. You're sure you can move your hand. So these patients have a longer period of recovery, if none. People started to investigate how this uncommon syndrome emerges in the brain. It is uncommon, but it's 32% of patients can encounter anosognosia for hemiplegia in the hyperacute stage. But then in the chronic stage, it's fairly uncommon. So people have tried to understand how and where in the brain anosognosia for hemiplegia occurs. And the reflection for the healthy brain would be where in the brain awareness arises. The problem that people encountered while studying anosognosia for hemiplegia is that it's a complex syndrome. Like if you read any papers about the matter, they start with anosognosia for hemiplegia is a very complex syndrome made up by different symptoms and co-occurring factors, such as external or personal neglect. I think you remember Michelle introduced us to the concept of spatial representation and memory problems. To further complicate the scenario, patients can display overt awareness. So if you ask them, can you move your right hand? They would say no. But then when presented with a tool like a tray, they would act as if they have a functioning hand. This is a very elegant paradigm by Cocchini and colleagues, 2010, where they presented various objects that required being manual use. And for the ashtray, if you know you can't move your hand, you would take it by the center, right? If you know you can move both of your hands, you would take it as normal you would do. So the two ends of the tray. And so they found out that people that overtly stated they can move their hand still show implicit unawareness for their condition by taking the ashtray as if they have both of the hands spared. And you can easily imagine the burdens of these patients that are sent back home, and they would behave as if they are completely functional. So they might endanger themselves and hurt themselves pretty bad. Very complex scenario, we don't know. But the first description of structures associated with anosognosia for hemiplegia I'm going to refer to it as AHP from now on, are on the opposite, pretty fair, pretty simple. It is a condition that it's linked to a damage to the inferior prefrontal cortex, or it is a condition that is linked to a damage, a specific damage to the insula. These two papers here are pioneer papers, and they both went out the same year, pointing to different structures. And the pointing to different structures carries also the theoretical description of the syndrome, because one said that it is a failure in the monitoring process that should drive and constantly monitor the movement of the hand, while the other says that it's an issue with the body representation. So in 2019, we were lucky enough to have collected enough patients to do a group study. And so we were ready to see whether there are structures that are specifically associated with AHP. And when I mean structure, I mean white matter structures also. And whether these structures work isolated or in integrated manner. So I told you, we were lucky enough to have a cohort of patients. 95 anosognotic patients are a lot. And this is the effort of Caterina Fotopoulou and Valentina Moro back at the time. It's 10 years of work. And I'm so privileged to have the chance to work with them. A classic way of assessing anosognosia for hemiplegia is by the BISIA score, that are basically questions, the same that I asked you before. So can you move your hand? Can you show it to me? Are you moving your hand? And the score goes from 0 to 3, where 0 is lack of unawareness, so good. While higher scores means the presence of unawareness. And then we selected the co-occurring symptoms that are mostly found in AHP. Of course, hemiplegia, so studied by the MRC. Memory, studied by the memory span. Extrapersonal neglect and personal neglect. Are we all familiar with personal neglect? Yes, no. Yeah, no. So personal neglect is a body representation disorder where patients ignore half of their body. It has always been discussed whether personal neglect is anosognosia for hemiplegia or not. The trick is that when the hand, the neglected hand, is placed onto the right field, attentional field, space field of the patients are aware that the hand is there and they cannot move it. Otherwise, they completely ignore. They dress up only the right side of their body, and it occurs very often with anosognosia for hemiplegia. We collected the CT scans of these patients, CT and MRI scans, drew the lesions on the scans, normalized them, and then we used the disconnectome to compute the disconnectome maps of all the cohort of patients. And then we analyzed the data on FSL, as I showed you yesterday. But instead of putting as variable of interest the BISA score in a continuous way, we split the group in two, basically. So the hemiplegic group and the control group. And then we added as nuisance variables age, education, interval between the scan and the assessment, the lesion size, and the neuropsychological assessment of personal neglect, extrapersonal neglect, memory, and motor deficits. It's a lot of covariates, I know, but we had enough patients, likely. It's not always the case, I know. The results pointed to both cortical, so gray matter, and white matter structures that were associated specifically to the anosognotic group. And we have subcortical structures such as the basal ganglia, the putamen, the insula, and the temporal pole. While the white matter structures that emerged are the cingulum, the superior longitudinal fasciculus, the third branch, frontostriatal tract, and the frontal aslant tract that connects medial frontal structures, such as the presupplementary and supplementary areas, to the inferior frontal gyrus. A bunch of structures, areas, tracts. What's the meaning of this? How they interact to create motor awareness? Do they do that in isolation, or we have to have a disruption of all of them to have awareness of our motor abilities? That's the question that we asked ourselves once we had the results. And likely Mr. Bayesian, Michele Scandola, jumped in and we assessed, first of all, whether all these structures are necessary to the arise of anosognosia for hemiplegia. And we saw that all white matter structures are necessary, while the gray matter structures are really weight on the symptoms only when considered together. So we created also binomial Bayesian models to compare all the combination. It's a hierarchical model, so all the combination of white matter tracts and gray matter structures to retrieve the winning model, that in this case, for each of the white matter and gray matter models were models with all the structure jointly waiting on anosognosia for hemiplegia. And then we compare the winning models to see whether gray matter structure are necessary or white matter are necessary, or the interaction of all of them. And we saw that the interaction of all the structures that emerged from the lesion and white matter analysis are necessary for anosognosia for hemiplegia. So in summary, we had the limbic system that comprehend the structures connected by the cingulum, the premotor loop that includes structure connected by frontostriatal connections, and the ventral attentional system with frontoparietal structures and the insula. Each of them has a specific component in awareness for motor abilities. The limbic system takes on the updating of the belief on oneself through the activation of autobiographical memory. The premotor loop allows to monitoring the error computed by the failed movement. And the ventral attentional system allows to shift the attention toward the stimulus, the significant stimulus that is the hand that doesn't move. But importantly, all the three systems work together to the emergence of a completely new function that is awareness for motor abilities. From this, we wanted to test whether these systems can be found also when looking for motor awareness in other etiologies such as Parkinson and Huntington disorders and other syndromes like the anarchic hand syndrome that we saw yesterday, or tics and Tourette syndrome. And we modeled three components of motor awareness. This is a review, so it's all based on the literature. And we split motor awareness is motor intentions, that is the conscious will of moving the body. The aware motor execution, that is the ability to monitor the error online, and the awareness for the general motor abilities, that is being able to predict whether I can juggle 5 balls in the air or not. I don't. And we split the syndromes according to whether they pertain to a certain category of motor intention or motor execution and awareness for general motor abilities. So we summarized all the structures that we found in these patients, both the patients with neurodegenerative disorders or patients with stroke, and their modalities of awareness for motor abilities. And we found again the 3 components, the limbic system, the limbic system with the disconnection of the cingulum, the insula, and the temporal pole, the premotor loop with the involvement of the basal ganglia and their connection to frontal areas, and the ventral attentional system with again connection of frontal parietal structures. What we did in this study was also to see whether we have correspondency in the healthy brain. So we identified motor intention, motor execution, and motor abilities in the damaged brain. But how are we studying these functions in fMRI, so in the healthy brain? And interestingly, we found that either the functions are defined differently. For instance, motor intention in fMRI studies is defined as conscious intention or sense of agency or multisensory integration or the silence network. Or we found that the complexity of syndromes like anosognosia for hemiplegia doesn't reflect in fMRI studies that looked for general motor abilities and pointed to a specific functions, like going back 20 years and see that only the premotor cortex is in charge of the sense of general motor abilities. And finally, going back to yesterday, we saw that some of the syndromes are not studied in the healthy brain, because we found unique single cases like anosognosia for theory of mind. So the awareness of our abilities to understand the others is not studied in fMRI. So there are gaps in our knowledge that might reflect in the way we study the functions in the patients. This means that we are missing out in rehabilitation, in diagnosis and rehabilitation of the patients. So we took a step back. I came to Bordeaux, started working with Michelle, and we wanted to see what is the latent organization of functions in the brain, how rationally have we studied those functions via fMRI, and if we can predict new functions that emerge by the interaction of cognition and brain, and that can be studied in future endeavors. To do so, we relied on the meta-analytic approach. We relied on the meta-analytic approach that allows to summarize the results regarding a specific concept by controlling for the bias carried by each type of specific study. And we relied on neurosynth I guess you're familiar with neurosynth. We already heard of it in these lectures. Neurosynth is a repository that computes meta-analytic maps according to specific terms. Back in 2019, Michelle and Slava Karolis already selected a number of cognitive terms. I guess it was 590. But when I started my project in 2021, some of the terms disappeared from neurosynth. So we ended up with a sample of 506 terms and associated 506 meta-analytic maps. All clear? Okay. We parcellated the meta-analytic maps and we used UMAP to explore the latent structure, similarities and differences between the sample, so the 506 meta-analytic maps, by preserving their relationship. So we obtained our morphospace where the maps that are similar cluster together, while maps that are different spread far away apart. Here you see it on the 3D view, and for visualization purposes, you can see it also in the 2D view. I'm saying visualization purposes because we tested the precision of the clustering of the maps in 3D and 2D, and the 3D one. So we kept the 3 dimensions. What do you see in the morphospace? It's not Rorschach test, just do you see any pattern? We saw the pattern. So the maps clustered in branches according to their functional domain. But here in the center, the maps were scattered. They belong to different domains, and we couldn't make sense out of it. So we said, why don't we explore what's going on in the center of the space? And we actually already had an hypothesis. So maybe they have been studied differently, those specific terms, those specific functions. Maybe we should look how rationally the function have been explored. And so rationality is defined as the logical and causal relationship among ideas to explain observations. And this logical and causal relationship, how we find it, how we test it in our research by a linear regression. And the product of the linear regressions are predictions. So I want you to think of the morphospace like a map. And if we want to predict how a place will look like at a specific coordinate, we might want to look at the similarity or differences with neighborhood places or far away. So a place here will look like this, with a sea and sandstone typical houses, while it won't have characteristics like mountains or snow. The same applies to the space. So to predict the map, the typical activation pattern of a map of finger movements, we will rely on the closest maps. It would be more similar to the closest map, but different from the maps that are far away. Everything in the space waits on the prediction of the feature of our map. But if we have a map that is disturbed, we can't really see the features, we will end up with a biased prediction. Again, the same applies with our space. So if we are relying on maps that have been poorly theorized or have flaws in their methods, we will have a flawed prediction. Coming back to our space, this is what we've done. We computed the Euclidean distances between each of the map in the space and the other. Used those Euclidean distances in as many models as the maps to predict each map of the model and correlated the original and the predicted map to extract a predictability index. The goodness of the precision of the prediction made by the linear regression. And yeah.
Can you do something similar to what Anna did, in the sense that you could take a bunch of studies in the 2D domain and try and see if a separate study coming still from nursing falls accurately or not in the...
We're getting there. Hold on, let's put a pin on that question. I'm coming back for you. That's very good. So these are two examples of well-predicted and poorly predicted maps. I'm so sorry, maybe it's too small for you, but what is this map here? Awareness. It's awareness. It falls in the center of the space, and you can clearly see it. You don't even need statistics to see that it has been poorly predicted. This is the original one, and this is the predicted one. While we have other maps, such as listening in the auditory cluster, that have a high predictability index. So good prediction out of the analysis. But if we zoom in, for instance, in the language branch, these are examples of language functions that have a high predictability index. And these are examples of functions that have a low predictability index. In my master's degree, during my master's degree, I was working in a lab that studied executive functions, and I was not surprised to see executive functions there. Again, it's a good way to see how well a function is defined if you read the first lines of a paper. All the paper in executive function starts with, executive functions are an umbrella term. If we all define executive function differently, how can we expect to find systematic results out of our experiments? So yeah, executive functions is in the center of the map with concepts like, yeah, sorry.
The terms like more specific executive functions, such as the inhibitory control.
More specific executive function, they are well predicted, exactly. Yeah, and I highlighted also these three functions because many of the terms, such as also awareness, fall in the center of the space were related with inner state cognition. And again, this is not surprising. It's really difficult to implement a task and define inner state cognitions and implement a task that captures inner states in the MRI. Okay, so we solved the problem, we solved the mystery of the center of the space. But what about our third hypothesis? So can we predict new functions by studying the relationship between the existing functions of the space? And remember, the space is just our brain cognition relationship, how the cognition is organized in our brain. To test this hypothesis, we relied on external data sets. So more maps from Neurosynth, new maps, 13. Maps from another meta-analytic repository, NeuroQuery, and maps from raw fMRI data that we selected from NeuroVault. Same drill as before. We parcel the map, and this time we projected the new map onto the space. The space stays as it is. It will never change. But the new maps are projected onto it, and we will explore where they land. Of course, they will land closer to the maps that are most similar to them, and far away from maps that are different. Yes?
Yeah, I just have a question. So the parcellation is the thing that decides where each spot falls in the UMAP projections?
The parcellation is a way to simplify the information of the maps, basically, because we have the maps in the MNI space. The parcellation simplifies, instead of having more than 10,000 of voxels, we will have 440 parcels. And that is used to retrieve like a structure latent into the map and also between the maps. So if the values basically within the parcellation are similar between the maps, they will cluster close to each other. Yes.
You try to see how the latent space is stable with different classes.
Yes, it's stable. Yeah. It's stable except when we apply random parcels. Random parcels, it's not stable.
All right, and one question is, neurosynth, if you're using it again, is there a risk of having correlations with it?
No, because these are new maps that were not present in 2019, and they were created after. Then, if the question though is, do we have a recursivity? So could we find other studies, the same studies in other meta-analytic map? Yes, but each of them will weight differently according to the main topic of the study. So they will be all different. Again, we projected the maps, and then we computed also for these new maps the predictability index by measuring the Euclidean distances between the new maps and the 506 existing maps of the space. In the results, I know it's dense, I'm gonna guide you through it. So these are the results for NeuroQuery. 888 new meta-analytic maps, and I love how they distribute following the branches of the space, with few exceptions, such as object manipulation, that is a map that was not present, like a function that was not present in the morphospace, and that falls between between the domains of action and motor. These are the maps, the new maps from Neurosynth, and I highlighted a factory that fell close to emotions, another thing that I loved. And these are the new raw data, raw maps extracted from NeuroVault. And here I highlighted Friend's prediction that landed close to decision making. So in this way, we confirm that we can predict new maps from the space with high or low predictability, but this depends on well the maps, on how robust the map is. We went farther. We pushed it farther, and we said, okay, this is for a task-based fMRI, but what happens with resting state or guided resting state? So we selected the same cohort as Michelle was talking about earlier, so the HCP movie dataset, and we extracted all the maps, is more than 3,000 maps, because we have activation per second. We parceled the map and projected all the map onto the UMAP, onto the morphospace. And we measured the distances between each of the second, so each of the activation per second, and the maps in the morphospace. And we extracted the closest map to our activation. And these are examples. So we have, for this frame here at second 0.21, this map lands close to sensory information. This is the very first frame of the movie. We saw it earlier. At 2:02, a subtitle appears, and the map lands close to communication. At 2:25, a guy was playing with a stick, and the map landed close to imitation. At 3:33, we have a very close shot of eyes, and the map lands close to the eyes map in the morphospace. And this is a cute video to show you online how it works. So this is the movie, these are the activations, and this is the map per second where it lands in the space. And this is the decoded activations. And my favorite part, because I come from body representation and action, this one. So people started to see the person playing with the stick, and the map is decoded as tools, imitation.
Marry the good man and marry the second man is the bad man. Marry that second man, he might have weapon or something. And if you start running after him, he'll get you.
Okay, so where do we go from there? You saw this already. Does it look like the morphospace? No, it doesn't. This is Marcella's map. You should know. So we projected all the cortical meta-analytic activation maps onto the white matter, and we created another morphospace. This is the white matter morphospace. Michelle presented very briefly earlier. Because we asked ourselves, how can we use the space to go back to the basics, to go back to the patients? Can we decode the results of our lesion and white matter analysis with the morphospace? Can we identify new functions with the morphospace? So if you're seeing me and Elizabeth chatting these days, this is what we're cooking. These are very preliminary results. We took a cohort of patients and looked at their scores in constructional apraxia. Constructional apraxia is a type of apraxia that prevents patients to copy figures such as these. Meaningless figures, but they're very complicated for the patients, and they fail in copying those. They might even have spared abilities of free drawing. So if they are asked to draw a flower, they can do it very easily. But they fail when copying meaningless lines and circles. So we run, as before, the lesion and white matter disconnection analysis, and we end up with this pattern of disconnection of the frontostriatal tract, thalamic tract disconnection, and the spinal tract. What we did was to take the disconnection map and treat it as we did with the fMRI maps. So we parcel the disconnectome map with the parcel provided by Marcella, and that they have been used to build the new morphospace. And we projected the constructional apraxia map onto the map that is made up by healthy, studied cognitive functions. And we looked at the at the maps that are close to apraxia, constructional apraxia, by measuring the Euclidean distances. And we have maps such as short-term memory, imagined, and sequences. So we are able to decode how we are measuring constructional apraxia in the patients. Of course, if we saw things like, I don't know, semantics or fluency, we might have a discussion to make about how we are measuring apraxia in the patients. We're cooking. There will be a GUI to do your projection onto the space. The parcellation will be embedded in the code, so you will have just to have your disconnection map in the MNI 152, put it in the model, use the UMAP morphospace that is provided in my GitHub, and you will have a list of terms associated with your disconnection maps and the coordinates and the Euclidean distances. Thank you.